All right, fifth graders, we're going to go over function tables today. All right, so we talked about this in class today. We talked about input-output tables and that we've used them before. And that generally you have an input, and those are the numbers that go in. You have a rule, which is applied to each of the numbers of the input. And you have your output numbers. And you can tell here that 2 matches to 8 because 2 times 4 is 8.
3, 4, 6.
Yeah. And you can tell that 5 times 4 is 20, 7 times 4 is 28, 11 times 4 is 44. So our input and output match each other by applying the rule. Here we have input of those 4 numbers, the output of that. When you have your input and your output and you have to figure out the rule, you have to figure out what is the same between each matching input and output. And for this one, we determined that it is -7, -7, adding -7, those types of things. Okay, so here's an example of an input-out table. We have our input, output, we have our rule. The numbers on the left of the input-out table are called the domain. When you write the domain, you put your brackets, your smiley face brackets, and you list your numbers in order as they go down the table. On the other side, it is the range. And for that, it's written the same way. You use your little smiley face brackets, and you put the numbers in order. When you have them in order, your functions should match. You need to make sure that you put them in order so your functions are matching. So again, input is the domain, output is the range. All right, so take a look at this. The rule for this input-output table is multiplied by 3. Remember what we talked about in class, that in order to make sure that the rule matches, how many times should you check it? And I hope for this one you are seeing that this is false. And we know what's false because 2 times 3 is not 8. 5 times 3 is not 20. And as you go down the list, you'll see that. All right, so for this one, I want you to look at the input-output tables, and I want you to see if you can figure out what the values in the rule are. Let's start on this one on the left. So I want you to pause right now, and I want you to see if you can figure out what the values and the rule are. All right, to do this one, you have to look at the ones you know. So for example, we have -2 to a +3. And down here, we have a 3 to a +8. So we're going to look at the relationship between those 2 sets of numbers. And when we can find the relationship between those numbers, we can find the rule. Well, for this one, I know that -2 and 2 and 3, I could think maybe on a number line. 2 and 3 are 5 points away on the number line. Once I think I know the rule here, I'm going to go down here and I'm going to say, oh, does it apply here? And yes, 3 and 8 are 5 points away. So I am going to go with a rule of +5. Check and see if you have that same rule. And if so, go ahead and apply it to the other unknowns and then check them. Okay, so let's check. So those are the unknowns. All right, so let's look at the next one. This one, we have our 2 things. We have 1 and 5, and 3 and 13 are the ones that are given to us. Well, I know the difference between 1 and 5 is 4. So I'm thinking maybe it's add 4. The next thing to do is to check down below. Let me see what happens if I add 4. If I add 4 to 3, I get 7. That does not match. So that doesn't work. So now I have to think of some other way that it could match. I'm going to look and say, okay, are there any other relationships I can do? I can see over here that it's increasing by 1 every time. My input is 1, my output is 5. Input is 2, I don't know what it is. Input is 3, output is 13. I'm going to look at the relationship between my outputs. And the difference between 5 and 13 is 8. All right? So between here and here is 8. And what about between here and here? So 121. Well, I don't know what this one is, so I don't know if that's sequential, so I'm not going to go that far. If there and there is 8, that means from here to here is 4, and here to here is 4. So I have an increase of 4 both times. Then write that a little bit different. And we're going to write it as an increase of 4 and an increase of 4. So somewhere, I wonder if 4 has to do with anything. Well, if the difference here was 8, and we do 4 and 4, 5 plus 4 is 9. So I'm going to check and see if I can find a pattern now. Okay, so when I look at it, I'm thinking that's 9, and I'm noticing that every time it increases by 4, which means it gets 4 times bigger on the right. Well, what if I do 1 times 4? 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. I'm starting to notice a pattern here. It gets 4 times bigger every time. 1 times 4 is 4. And 5 is 1 more. 2 times 4 is 8. 9 is 1 more than 8. 3 times 4 is 12. And that is 1 more than 8. So I think I've determined my rule. I found a pattern. Now, it wasn't an easy pattern to find. I really had to do some thinking and some other math. I had to look at the relationship between some unknowns and think about those things. And I think the rule is times 4 plus 1. Because all of the input tables, if I multiply them by 4 and add 1, I get the output tables. So if you did not get that rule, I want you to go back and I want you to look at it. And I want you to figure out somewhere where you could have found the hint for that. If we apply that rule, we would get 9. We would get 17. Now we have a case where we have the output and we have to find the input. The rule for that is to reverse your rule. So I would take 121, and instead of adding 1, I would subtract 1, which would give me 120. 120 divided by 4 would give me 30. And then here, 100 times 4 is 400. Plus 1 is 401. All right. So when you look at a function table, we can also write functions as sets of ordered pairs. Remember, ordered pairs you remember from doing coordinate grids where you go x times y. All of the x coordinates are the input. So if you looked at a function table and you thought of the input as the x coordinate, and you would think of all the outputs as the y-coordinate, you can make a set of ordered pairs.
177 is now dismissed.
To figure out the set, you make a function map first. The ordered pairs take the values for the domain, which is x, and match it with the value for the range, which is y. And we write an ordered pair as domain, comma, range, or x, comma, y. So for example, here we have 2, and here we have 3. We would write that as 2, or negative 2, 3. The next one, we have negative 1, 4. And we keep writing it like that. So written out completely, the functions of this table are written as, and there we have our little smiley face parentheses, and then I have each function with the domain paired to the range for each of them. Okay, I want you to go ahead and look at this, and I want you to write. I want you to write the functions of this table. Okay, so looking at the functions, pause the video and write down the functions, and then come back and check. Okay? The functions are 1 and 5, 2 and 9, they're right next to each other, 3 and 13, 4 and 17, 30 and 121, 100 and 401. All right, another way to look at function tables is they can also be written horizontal. They are not always up and down. When you have a horizontal function table, you think of the top set of numbers as your domain. They would be your x. And the bottom is your range. That would be your y. So here, this would be our x, and that's our y. So if we looked at that, our domain is 1, 2, 3, 4. The range are 42, 84, 68, and 36. Our functions would then be written like this. If we wanted to look for a rule, we needed to look for what happens between here and there. So how do we change from that to that? And that's how you would look for your rule. Take a second and see if you can figure out the rule for this function. Okay, so we can also look at our function table and we can make a rule, but we can write the rule as an equation. And since y is the result of something happening to our x, y is the end result, our equations are going to begin with y. Then, since we list the rule as an expression on the other side of y, we show the operation that is used to turn the value of x to the value of y. So for example, in this one, y is our output. The rule is what happens to x. So it's kind of reversed. So it looks different. Now, if you wanted to write it like that, you could. However, you're usually going to see it with y written on the other side. And what you can do by finding the rule and writing it as an equation is much easier to find unknown values. So for example, on this one, if I replaced this function into my equation, I would have 4 equals -1 plus 5. And that's a true statement, so I know that that matches my function. Okay, so I want you to go ahead and look through these 6. See if you can figure out the equation on the first 2 for number 4 and for 2, 3, 4, and 5. And number 6, apply the equation to the table and find out your values for y. Okay, make sure you pause long enough to check each one. So go ahead and check. This one should have been y equals 5x. Y equals x over 2. If you put y equals x divided by 2, that would be okay. I would prefer x over 2. Y equals x minus 3. Y equals 3x plus 2. And then here we have the equation y equals x squared. And that should have been your answer. So go ahead and check those over. If you got them wrong, go back and see if you can figure out where the pattern is so you know where to look next time. All right, that's it. Go ahead on the Moodle, and I have a functions table quiz for you to do.